Hello and welcome to Logic. This is Cedric speaking. I'm super happy to welcome you in this brand new video in which we're going to talk about robot painting. This is a tutorial video that's going to be quite short. The aim of this video is to cover most of the features for you to start with a painting application. Obviously, it's the very first of a kind, and we really hope that we're going to generate several kind of these videos within the next weeks and months, covering different kind of applications to show you how versatile Logic is. To start up with this painting application, we're gonna obviously start with building our scene. This means bringing first a robot. For this application, we choose the KUKA robot, the KR12. So waiting for the collision environment to build. Obviously, with the robot, we're gonna need this time to bring a tool or specific tool dedicated to painting. We made a custom tool that's gonna be 100mm width. We make sure that the TCP is set correctly. Normally, there is no way to set a specific touch point to the flange of it. Just make sure that with a small image, everything is fine. And when everything is set, you just bring it to the scene. It should be normally directly attached to your robot. You obviously have a vision of your geometrical coordinates to make sure that your TCP is correctly set. Now we bring into the scene the object. For this painting application, we choose an old-fashioned propeller from a plane. It's going to be perfect because it has round shapes, it's pretty long, so it's convenient for the kind of robot that we're using here. Once this is brought to the scene, you just obviously bring the object close to the robot in order to make sure that the robot is going to be able to reach every point of the propeller. For this application, we decided not to cover all the propeller to run it a bit faster, so we're going to focus on only half of it. Once your scene is set, we go to trajectories. We're going to start first to set a safe position, which is the homing position. You just give a name to the actual TCP position of your robot. So here we're gonna call it home, and we're gonna come back to this position a bit later. Here the main generator that we're gonna use for this painting application is called the cursor pose. The point of this generator is quite simple, is as its name indicates, you just click on any kind of element of the surface you would like to cover, and you let the magic happen by adding all the waypoints in the trajectory that you just created. You obviously are able to create as many waypoints as you want as soon as you're clicking on the right surface. Once this is done, you can obviously choose to handle the waypoints. We choose to bring another generator into life, and we're going to use the safe position generator. Remember the homing position that we just created. So we bring two positions related to this homing position, one at the beginning and one at the end, in order to make a closed loop trajectory. We just check that once the generation is set, everything runs smoothly by making a preview of it. Here we can see some collisions happening between the tool and the propeller. It's because we faked a spray from the painting tool. So here we're just going to the collision filters, and we decide to set a non-collision between the propeller and the tool in order to make the collisions disappear to run the application. Once this is done, we just make another preview real quick to make sure that all the collisions have been avoided. From now on, as we are in a painting application, what we're gonna do is that we're gonna do an overspray. This means that we're gonna handle a few waypoints that are on the very edges on the propeller, and we're gonna deplace them, we're gonna move them a little bit outside of the propeller to make sure that there is a spray beginning before and after covering the propeller. This means that you're gonna get a more homogeneous spraying over the material. Here again, making a small preview of it, make sure that the trajectory has been generated correctly with the overspray. Now what we're gonna do is that we're gonna set an exchange table in order to simulate a request from an external PLC to give the order to your robot to generate the spray. Here what we're gonna do is that we set an input. The input is gonna be called first activated tool. It's gonna be a boolean and with an initial value of 0. Once this is set, we give it to the actual exchange table, and we do the same for the output signal. We remove everything that was existent so far. We create a new output that is going to be called activate output. We're going to set it also as a boolean with an initial value of 0, and we move it to the exchange table. Once this is done, you go back and you make sure that the exchange table is actually active. So there's going to be a communication within 3D Studio between everything that has been set and this kind of faked PLC. Now you're calling the input and output that you've been generating and creating, and you're going to link them to positions, as many as you want, within your trajectories. Here we link the input and output to the oversprayed position, so position 2 and the one before last position, to give a kind of signal saying from this position you can start spraying and you can start your painting activation. From now on, you have your entire application that is ready to go. One extra thing that I would like to do is to show the robot thread. This means that we want to be able to see what is actually the spraying tool covering in terms of surface, to make sure that we're not missing a single point and to make sure that we have the most homogeneous surface covered on the propeller. We set it to a linear one with 100 mm of width. We regenerate the trajectory, and we're gonna make sure that everything is working completely finely. We make a preview that is actually set at almost 20 mm a second. This would be potentially the real pace of the robot that you can obviously modify and optimize. We are just advancing a little bit to reach directly the overspray point, and here you're gonna see there is a break time that represents when the exchange signals would be happening between 3D Studio and the PLC. If you are connected to the real robot and to the real hardware, obviously you would have to receive the actual signal, but you have the possibility to force the signal also within 3D Studio. That's all for this very first tutorial that we made here inside 3D Logic Robotics offices. We really hope that this video is gonna be completely fine for you, that will be understandable, and we really hope that you can replicate this. Of course, make sure that you follow us on our social media. We can't wait to see what you're gonna be able to achieve with 3D Logic in the near future. In the meantime, stay connected and see you very soon.